Thank you for the opportunity to speak here. Today, we are going to speak about highly strain rate sensitive polymers, such as the Rheon polymers, and the role in dynamic support in sportswear. But before I go too much into dynamic supports in sportswear, I wanted to ask who knows what a highly strain rate sensitive polymer is? Okay, so a highly strain rate sensitive polymer is a material that is dynamic. It has a different set of properties when it's resting and when it is subjected to force. The easiest way to explain it is actually with a product. This here is a helmet component made with Rheon. It's part of the Zenith Shadow XR helmet, which is an American football helmet that won the NFL Head Held Challenge a couple of years ago. You can see it's very soft and flexible when I press it. But when I impact it, it stiffens and it absorbs the energy. So soft and comfortable, yet stiff and protective. And this kind of dynamic property is what we're going to leverage throughout this talk for a completely different application in apparel. So what are we going to speak about today? I will give you a brief introduction into who we are and what we do. We will then go very briefly into the science behind these highly strain rate sensitive polymers. And then we are going to go into a case study with one of our brand partners, Soar Running, and the product we launched with them a couple of months ago. So who are we? We are a London-based material technology company, and we specialize on highly strain rate sensitive polymers. What you can see in this video here is one of our products. That's a shin protector. You can see that this shin protector is very flexible, very soft at rest, but when you impact it here with a 50 joule impact, it stiffens and it absorbs this energy. Usually when you think about something which is protective, you think about something which is stiff and protective, therefore uncomfortable and protective. What the dynamic nature of Rheon allows you to do is to combine comfort with protection. And this kind of dynamic property is what we're going to see throughout the talk. And when you subject this type of polymers to force, there are two things that happen. The first one is they stiffen, and the second one is they dampen. So we saw how this works under impact with this helmet component or the shin guard. However, it also works when the force is a vibration or when the force is tension. And in this talk, we are going to focus on tension. So for tension control in garments, we use thin Rheon films, which are heat laminated onto close-fitting garments, such as running shorts or bras. And a strain rate sensitive film is a film that you can stretch slowly, and it's going to be very stretchy and flexible, similar to this component. But when you stretch it fast, it stiffens and it dampens. And the product we're going to speak about today is a pair of trail running shorts that we launched in collaboration with Soar Running, and I'm going to show you. So the pair of running shorts we saw have Rheon film heat laminated with certain patterns on the main muscle groups, which are quads and hamstrings. Essentially, when you're running, your muscles shear. They shear out of plane, which makes you a little bit less efficient as a runner. Conventionally, this has been addressed in industry by using compression garments. However, compression garments are not very comfortable for athletes. What Rheon allows you to do is combine comfort with support. What you can see in this video here, you can see a runner, and you can see how the muscles of this runner are shearing. They're wobbling out of plane. And this muscle shearing or muscle vibrations, they have been previously associated with an increased fatigue for runners, increased muscle damage, increased recovery times, as well as a reduced proprioception for athletes. The graph here shows in white the radial muscle acceleration of a runner with conventional running shorts, and in blue in a pair of running shorts with Rheon heat laminated onto it. What does it mean? We worked in collaboration with the University of Wisconsin-Madison and Progressive Sports Loughborough to study what the effect is of adding Rheon onto close-fitting running shorts is. And what they did is they looked into 3 different conditions. A pair of conventional running shorts with no compression, here called zero compression shorts, and 2 compressive conditions. The first compressive condition was a pair of conventional compression shorts, and the second compressive condition had Rheon heat laminated onto it. What is important to note is that the Rheon shorts and the baseline compression shorts had the same level of compression and support at rest, so the same level of comfort. However, when the athletes started running, the Rheon shorts reduced these muscle vibrations by 23% compared to the conventional compression shorts, and by 39% compared to the zero compression shorts, which is significant. And we can do that by leveraging these highly strain rate sensitive properties of the polymer. What you can see here is the comparison of 2 textiles. In gray, you have a conventional stretch textile with elastane, tested at 3 different speeds, between 30 millimeters a minute to 3,000 millimeters a minute. And what you can see is, regardless of the speed you are stretching this material at, it has the same level of stiffness and the same level of damping. In blue, you can see a textile system with Rheon heat laminated onto it. And what you can see here is that the faster you stretch it, the more it stiffens and the more it dampens. So it translates to having a pair of running shorts which is soft and comfortable when you put it on and when you walk in it, but when you start running and your muscles start shearing, it provides you with dynamic support, so support when you need it. And I spoke a lot about material properties, but we also use computational design methods to enhance these material properties and optimize them for certain movements. Our computational design methods take biometric data into account, such as muscle movements, joint movements, and soft tissue movements, to then generate patterns that are optimized for the movement of this specific muscle group. Here we see the product in recent races, so for example in the recent UTMB race, and worn by other athletes. At Rheon, we like to work in collaboration with our brand partners, especially when we are launching new technologies such as our Rheon yarn, which we are currently developing, or Rheon 3D printing. With this, I'd like to sum up this talk. I briefly spoke about what are highly strain rate sensitive polymers and how they work, also how they are applied in performance apparel. I showed an example with saw running, but we also have products with Adidas, as you can see here on Gao. Another area where this highly strain rate sensitive technology plays a role is actually in sports bras, where you can combine comfort and support for female athletes, or in vibration damping, for example, in cycling shoes, as well as in head and body protection. The helmet you can see here in this slide is the Zenith Shadow XR helmet, where this component comes from. With this, I'd like to thank you for your attention, and come and find me in the break.